Hello! Today we are going to be talking about attributes of the cosine graph when it is shifted or transformed. But before we do that, we need to look at the attributes of the parent function. Our first attribute is the domain, and the domain for our cosine graph is all real numbers. Our range, so our y values, our range go from -1 all the way up to 1. And both of those values are included, so we use our little brackets. Alright, our maximum, no matter where we are on this graph, is always going to be at all of these little peaks. And that peak is at 1. So our maximums are 1. Our minimums are all at these little valleys. And all of these little valleys are at -1. So our minimum is -1. Our zeros is when our graph crosses the x-axis. So here we have one here, 1, 2, 3, 4 on our graph. So let's list those 4 out. So this one's -3 pi over 2. Our x value here is -pi over 2. And then on the other side of the graph is pi over 2. And this one is 3 pi over 2. Alright, now we're going to talk about the intervals when it's increasing and the intervals when it's decreasing. This graph is increasing when it has like a positive slope. From here to here it's increasing, from here to here it's increasing. So this graph is increasing from -pi to 1. It is also increasing from pi to 2 pi. Okay, let's see when it's decreasing. We can see it's decreasing on these little down slopes. So it starts at -2 pi. And the turning point is at -pi. Alright, and then that's when it starts increasing again, and it starts decreasing again at 1. And it stops decreasing at pi. And those are our attributes for our parent function. So now let's look at the cosine graph when it has been shifted. Y equals cosine of x minus 1. So this -1 means our graph was shifted 1 unit down. So instead of our y-intercept being at 1 like it normally is for cosine, it's at 0. So our domain for this one is still all real numbers. We've not done anything to affect our domain. However, our range has been affected. Our range is now from -2, that's the lowest point it's going to be on the graph, to 0, which is our new highest point it's going to be on the graph. Alright, I just said the highest point on our graph is 0. And the lowest point on our graph is -2. Our zeros is when it hits the x-axis, and on this graph we see it hits the x-axis right here at 0, and it hits it again all the way over here at pi over 2. I mean 2 pi, excuse me. We see this graph increasing. It goes up right here. That increase starts at pi. And it starts turning back to go the other way at 2 pi. Decreasing, it starts decreasing at 0 and starts turning around again at pi. decreasing from 0 to pi. For our second example, we have y equals cosine of x minus pi over 2 minus pi over 2. Since we have a negative sign here, it means we're shifting to the right, and we're going to the right pi over 2 units. So here's pi over 2, which means normally this is all the way over here, but it's been shifted over, so now the start of our graph, which was normally at the y-axis, is now at pi over 2. Still the same graph, just moved over. So our domain, still all real numbers. Our range, so our lowest point is -1 and our highest point is still 1, so our range has not changed from our original graph. Our maximum is the same, our minimum is the same. Alright, let's look for our zeros. We have a 0 at 0. There's another one at pi. And there's another one on this graph at 2 pi. We see this one increasing from 0 to pi over 2. And increasing again from 3 pi over 2 to 2 pi. Our decreasing values start here and end way down here. So decreasing at pi over 2. And we turn that around at 3 pi over 2. Example 4 is y equals negative cosine of x. Our negative in the beginning means that our graph has been reflected over the x-axis. Our domain is still all real numbers, which could also be written as negative infinity to infinity. Our range goes from -1 to 1. Our maximum is 1. And our minimum is -1. So those values have not changed from our parent function. Our zeros are pi over 2. And on this graph we see another one at 3 pi over 2. Our increasing value is from 0 to pi. And it's decreasing from pi to 2 pi. Example number 5, we have y equals cosine of negative x. The negative inside the parentheses means it has been reflected over the y-axis. So for this one, our domain is still all real numbers. There's a little arrow here. I just didn't finish drawing the graph. So domain is all real. Range still goes -1 to 1. Our maximum is still 1. Our minimum is still -1. Our zeros on the negative side of the x-axis are -3 pi over 2 and -pi over 2. We are increasing from -pi to 0. And we're decreasing from -2 pi to -pi. If I were to continue drawing this graph, it would look like that. Does this look familiar? So here is our graph that we just finished drawing, and here is our parent function. They look the same. So even though it's been reflected over the y-axis, it's the same graph. So since it's symmetrical about the y-axis, cosine is an even function. Example 6, y equals 2 cosine of x. The 2 in the front means that we have vertically stretched this graph by a factor of 2. Our domain is still all real numbers. Our range now is a little bit different. We no longer go from -1 to 1. Now it starts at -2 all the way up to 2. So our range is now -2 to 2. Our maximum value is 2. Our minimum value is -2. Our zeros, we could see, are at pi over 2 and 3 pi over 2. We are increasing from pi to 2 pi and decreasing from 0 to pi.